So let's get started with the discussion today. So last week we had 4 sessions which were focused on specifically on a process for looking at how we can think creatively, and hence which hopefully would also lead to some kind of innovations. We looked at 2 processes. One was this whole process of identifying what all can be changed and what all remains constant. So identifying the variables and also putting them in categories, that which all are dependent, which are independent, and which all need to be controlled. That was one process. Second process was the scamper technique. And together these 2 processes, as you practice them, because otherwise in itself, no one can make another person more creative than he or she was in just 4 sessions. The sessions only introduce a process. What we are going to do in the sessions this week is focus on one of the 5 literacies which have been recognized internationally by different countries. So if you look at any of the literature published by organizations like UNESCO, etc., the time that we are going to face when you all will grow up as adults and take different roles in the society, there are different type of abilities that you would need to exhibit to live your life in a meaningful manner and also contribute to the society in a meaningful manner. So those 5 literacies which are listed, that includes the reading writing literacy, which for ages we have recognized, but there are other 4 literacies, which includes the scientific literacy, mathematical literacy, IT literacy, and financial literacy. So their scientific literacy and mathematical literacy, both of them, I suppose they were required even in the era, let's say 50 years or 100 years back. But we are recognizing it more clearly now. And financial and IT literacy are probably something new, which is more of an effect of the changing times. We are going to focus on scientific literacy. And the reason we like the term scientific literacy is it's not about everyone becoming scientists. It's about having that basic literacy. It is same as reading, writing. If I know how to speak in a language, understand a language, or read or write a language, doesn't mean I'm aspiring to become a poet or a writer, a book writer. But I still know enough for me to be able to communicate in whatever role I take. In the same way, I may not be a scientist, but I know how to think scientifically. And the reason thinking scientifically is becoming even more important in today's world is in terms of information. If you notice, you have information all around. That wasn't the case during my childhood. If we had to find information on any new topic, we had to go searching for the specific book in the libraries, and finally it boiled down to how rich the library could be and how much time you can spend in the library searching for the appropriate book. But the side effect of having more information is you sometimes have conflicting information, and it really, the real challenge is to figure out which information to believe in. Let me give some examples using my slide. I have 3 different situations. The very first one is how much water one should drink, right? And some of you may have also heard different opinions on this basic question. One of the opinions is written here in the slide, which people also call as water therapy. And these people, they advocate drinking around 1.5 liters of water every morning, which if you actually try doing it, it's a large amount of water. And many people say, no, not 1.5 is not enough. You drink 3-4 liters. And in general, more water is good for you. But there is exactly opposite line of thought that if you push more water than required, so if you are not thirsty, you are still drinking water, then your kidneys will experience more stress, and hence it's not good for the body. So which one do you believe? And the reason some of these questions are important is because they are directly related to our daily life. I can't not take a stand. I can't be neutral about some of these questions. Let me share a few more examples. And as always, on all of these discussions, as thoughts come to your mind, keep putting them in the chat window. If you want to unmute and speak, raise hand, and Ashray and Javeria, they are monitoring the raised hands throughout, and they'll request one of you to unmute and speak. I see that somebody has unmuted. Please go ahead and speak. Okay, maybe let me give another example. There is another thought process, which is about should we cook food at all or not? And in a way, it's opposite to what humans have been celebrating, that one of the unique things about humans is our ability to create fire, and that has had so many ripple effects on the different civilizations. It was revolutionary, right? And one of the things we started doing using fire is to cook food so that our teeth and rest of the digestive system doesn't have to work too hard. But there are a set of people who believe that raw food is good for health. And in fact, if you notice, salad, etc., is considered healthy. But on the other hand, people also say that no, we should eat hot food, cooked food, because it kills bacteria, plus the temperature being warm, it's good for the chemical reactions to kick in, because you may know that for any chemical reaction to the rate of reaction depends on the temperature of the environment. So when the temperature of food is high enough, then the enzymes, they are able to react faster and help with the digestion more easily. So which one do you believe in? Do you believe in eating raw food, or do you believe in eating only cooked food? And of course, I guess the way
the raw food is good because it's good, but you have to wash the food, wash the vegetables before eating it.
You have to wash the vegetables before eating. Okay.
The germs and bacteria will get killed.
So you are saying when you wash, at least the bacteria which water is able to carry, let's say things which get dissolved.
When we vegetables or fruits with a hot water, so that the bacteria and the viruses will get killed.
Oh, so you are saying wash it with hot water. Okay. Yeah, Tanish, exactly. So I knew that most of us would say, no, let's have a balance. Let's eat some cooked and some raw food, right? Which is the most common stand that we take, that can we have especially when you have two extremes, two opposite points of views, we try to take a stand that can I stand in between. One of my known contacts, he went to an extreme with the raw food, and for a good 2 years of time he didn't eat cooked food, and then one fine day he fainted and he was taken to the hospitals, and apparently his system internally had some worms, and people had all kinds of theories after that. And this is a real, I'm not cooking up the story, but this was actually one of the very learned people. It's not that someone just crazily tried the experiment. And that's why people would say that, yeah, maintain a balance. But more important question is, what's the basis of having either of the two thoughts? Balance is okay, but if I were to believe one, which one? So is there some truth in either of the two theories? And if you look at thinking scientifically, it's all about, so there are so many aspects where we have our beliefs because we have to take a decision, but we are not fully sure. It is based on some assumption and our past background. But when you think scientifically, because you are relying on data and observations, you are fully sure about it. Or even though you are unsure, you are also clear what are the assumptions that you are making. And that's all scientific thinking is about. And what we are going to do is these 4 days, we'll pick 2 activities. For each of them, after performing the activity, we will have one problem statement, one question, for which we are going to try and find answer using the process. So that way we'll, and the way we had it with creativity, even here it's a process which gets introduced in these 4 days. The real impact of the workshop will be visible when you'll practice it on a regular basis, because that's when it becomes a part of our thinking process and becomes a habit. And in that case, it's not then it will start showing up not only in the science experiments that you do, but also in all the other daily life aspects when you start raising those questions and start looking for data. Okay, so let us get started with the activity today. I think somebody had asked on the chat window as well that are we going to do an activity? So yes, we are going to work on electrolysis, and Shivani will take you through. After that, let's come back and discuss on the problem statement.
So hello everyone. So let's get with the activity. So what you'll be needing is 2 nails and 2 wire of length 30 centimeter, water 200 ml, or you can take 1 cup water, and you need salt 3 spoons. You need 1 battery and insulating tape, and also tissue or filter paper. Anything is fine. Okay. So yes, first you need to take water. So can I know how many of you are doing with me? Okay. Yes. So you need to take water, 1 cup, and add 3 spoons of salt. Mix it. Just keep it aside. So let it dissolve in the meantime. Okay. So for now, take a battery and the 2 wires of 30 centimeter. Okay. So we'll take these 2 wires and just put it on both the terminals of the battery.
What will we do after we add salt?
Okay, so just keep it aside. Add salt and keep it aside. Now take the battery. Take 1 wire and just tape one side of the wire. Let me see how many of you are doing.
Shivani, you have removed the from the wire, right?
I could not hear you, Deepa.
You have removed the insulation cord from the wire, right?
Sorry,
And
Deepa, I think
expose
there's
the
some internet
inside
connection
wire
or your
before
side, you're breaking off too much for us to be able to figure out what you're saying.
Okay, so I'll just repeat again what I'm doing. Okay, so there are like two wires, right? So I'm just simply taking one wire and attaching at one terminal using tape. Okay.
Am I audible now?
Yes, Deepa.
Yeah, the end of the wire, the insulation part has to be removed before you tape, right?
Yes,
Yeah, I
yes.
think you missed telling that. Probably
Okay,
that's it.
okay. Yes. So just secure it very well. Taking the other wire. Okay. So now what you're supposed to do is,
Ma'am, should we stick the wires to both the terminals? Two wires,
no. So both are separate.
positive terminal and second wire will be negative terminal.
Yes, yes. But don't stick both this end, okay?
Okay.
Yeah. Can see only two of you have on your video. I request everyone to turn on their videos. So up to here it's done. Okay. Yeah. So take one terminal and then okay, put a little bit more of this wire using this scissor. Okay, a tip of the scissor. Oops. Just wrap it around the needle. To secure this, just put insulating tape. So one of the wire. So I'll do the same with the other end. With the other end. Okay. And secure this with insulating tape. Okay. So it will look something like this. Okay. So up to here is done. So I can see only Vinyashri doing. Is anyone else also doing?
Ma'am, I am also doing, but I'm on my PC, so the webcam isn't working, so I'm not able to switch on
Okay.
the camera.
Okay. Okay. Anyone else?
I didn't have the materials today, so I won't be able to make it.
Okay.
I'm also working, but I'm actually struggling with putting that insulation tape over the battery along with the
Okay.
wire.
And the
Okay.
wire isn't sticking to the cell properly. It's
Okay. So I'll just wait for 2 more minutes.
Okay.
Yes. So up to here, it's clear, right? What did I do? I did nothing but took a battery, took 2 wires. Along these 2 terminals, I attached 2 wires and 2 nails. That's all. Simple. Okay.
Ma'am, the wire isn't sticking to this cell terminal.
Okay. Just try it. Try it. Just take a bigger one. Even I was facing the same problem.
Ma'am, I'll not be able to do it today because
Okay.
I don't
Okay.
have the materials.
Okay. That's fine.
Ma'am,
Yes.
ma'am, I'll not be able to do it today because I don't have the materials right now.
Yeah, I heard you. Yes. So, okay, I'll move on. Okay. So now what I'll do is,
Ma'am,
yes.
ma'am, I have arranged like this. Is it correct?
Yeah. So how much you are dipping that? The liquid? Yes. That's right. Yeah. So the way Mohana did, I'll do the same. So what you need to do is stick those two needles. Like this. So I'm securing that with again insulating tape. So I'm dipping approximately 5 centimeter of the nail inside the salt solution. Yes. So my setup looks something like this. Okay. So the moment you dip the cathode nail, we'll see those bubbles there. You see that?
Yeah, it is visible.
So now you need to leave this aside for approximately 10 minutes. So, and then what you need to do is, in the meantime, we'll make a setup where we'll filter this solution, okay? So for that, you need a bottle, and I'm going to cut along with this much part, okay?
I guess, Shivani, we
No
can
need.
skip the filtration part,
Okay,
given that there's a very specific problem we want to address.
Okay. So I'll just show the final thing. So when you leave it for 10 to 15 minutes and filter, you will get something like this. Okay. Yes, Vishal. We can take it.
Ma'am, what is that you're showing?
So this is the thing which is getting corroded, okay? So the corrosion is taking place over here and that is getting settled in the solution. That is this.
Ma'am, after arranging the setup, I can see that only from one side I'm getting the bubble.
Yes. That is the
One
cathode.
nail.
Yes.
Why, ma'am?
The reaction corrosion will only take place in the cathode.
So can you identify which nail, so to the battery, which terminal is that nail connected to?
I think it will be the negative terminal.
Okay, can you observe and confirm? Another question to look for an answer to is, what do you think, which gas is getting bubbled at the nail?
Hydrogen.
Hydrogen gas.
Okay. And so the end which where you are seeing the bubbles, as I think Mohana said, right? It's happening only on one of the two nails. Did anyone confirm whether it's connected to the positive terminal of the battery or negative terminal?
Sir, it is negative terminal.
Yes, a negative terminal.
It is connected to negative terminal. Okay. But Prisha is saying the opposite. So Prisha, can you share where are you seeing the bubbles?
No, sir, actually I'm saying negative terminal only.
Okay, you are also seeing it on negative terminal only. Natik, you have been asking this question. I'm not able to understand. What Google form are you looking for? Assignment. I mean, we are having some discussion right now, so I don't think you need to worry about the assignment right away. Okay, so two questions we looked at. One is, which terminal do you see the bubbles? We noticed that only one of the two nails you are seeing the bubbles. And the observation you all have is the nail which is connected to the negative terminal of the battery. There you are seeing bubbles. Second question was, what's our guess which gas this is? And some of you responded saying hydrogen. And where do you think this hydrogen gas is coming from?
From salt.
So what is the compound that you have in salt?
Sodium chloride.
Sir, I
Sodium
think
chloride.
that hydrogen is coming from the water because the oxygen and hydrogen are getting separated.
Okay. So now we have two different responses. One is that the hydrogen is coming from salt. Other is that it's coming from water. Okay. Arav is also saying it is coming from water.
So it's because of the mixing of water and the salt.
So if we don't mix salt, can water be split into hydrogen and oxygen?
No, sir. Sir, because current passes from current could not pass from distillated water. It can pass from after it is mixed with something like salt or sugar.
Okay. So instead of salt, if I add sugar, that would also suffice. Also, second question is, we have not used distilled water, right? We just used normal water. So is normal water a good conductor of electricity or bad conductor?
Sir, tap water is a good conductor of electricity.
Okay. So then if we use tap water, will we be able to split water into hydrogen and oxygen?
Yes, sir, we do not
yes,
need
sir.
salt.
We don't need salt. Okay. Okay. So so then that is the question we are going to come to. Let me go back to one more basic question. So we are saying hydrogen is going to the negative terminal, the nail which is connected to the negative terminal. Where is oxygen going?
Sir, to the anode.
Okay. And what is an anode?
Sir, connected to the positive.
The nail which is connected to the positive terminal of the battery, you are saying oxygen is going there. Do you see any bubbles there?
Sir, it is reacting with the iron. Corrode.
It is reacting with the iron. So do you see anything falling from the one of the two nails, or anything getting deposited on any of the nails?
Sir, a brownish kind of a powder.
Brownish structure.
Okay, and
Brownish layer.
Is that happening from both the nails or only one?
From
Sir, only one.
Sir,
only
Can,
one.
can you show?
sir, only one.
Any of you, if you can show you are giving a top view, Mohana. Can you show from the side, because from here it's difficult to make out. Yeah. So which side are you seeing the brown deposits? The side which has bubbles, or the side which, or the other nail? Oh, you are seeing it at the bottom of the bottle. Okay. Can you observe and check if it is falling? So where is that brown deposit coming from? Is it coming from both the nails or only one of them? And someone else may also answer. Mohana is, I think, still figuring this out.
Sir, it will come from the negative one only, sir.
The nail where hydrogen is getting bubbled.
Yes, sir.
Okay, so then what do you think that brown particles are?
So the brown particle is the rust formed on the iron.
Okay, and what is rust? What compound is rust?
Sir, ferric oxide.
Ferric oxide. So what are the elements in this compound? Ferric oxide. What will it be made up of?
Iron and oxygen.
Sir,
Iron and oxygen. But we said that the terminal where hydrogen is getting collected, there we are getting ferric oxide. Shouldn't it have been something made from iron and hydrogen? In a way, the question I'm asking is, which of the two nails do you expect to get rusted after the reaction? After you leave it for 10 minutes, which out of the two nails do you expect to get, collect the rust, the ferric oxide powder?
So the nail which is not in which where the bubbles are not being formed.
Okay, okay. So that's your prediction. And let us observe and confirm these predictions. Okay. So Prisha is saying she expects the rust to be formed on the nail where you are not seeing the bubbling, because again it's dependent on the theory that the nail which is showing the bubbles, that is having the hydrogen gas, so oxygen is going to the other terminal, and hence that nail will get rusted. Okay, let me share the problem, the question that I have for all of you. I'll take help of some of the slides for that. So as we were just discussing, do we require salt for electrolysis to happen, or can it happen without that as well? And one of the lines of thought we had was if water is able to let the current pass through, if it's a good conductor of electricity, then salt is not required. And let's say tap water, which we believe is a good conductor of electricity, if we use tap water, then we don't need. Then why did we add salt to the?
Sir, I think to speed up the rate of electrolysis.
Okay, so if that's the case, then if I add more salt, will the rate of electrolysis increase further? And that is the question that we are going to find an answer for. So you are supposed to figure out the impact of concentration of electrolyte. What does that mean? Say I put 1 teaspoon of salt in 100 ml of water and conduct the electrolysis experiment for 10 minutes. And after that, I collect all the rust which is collected on the nail. Let's say If it's happening only on one nail, then I collect that. If it's happening on both the nails, I collect from both. And based on the amount of rust collected in 10 minutes, I'm going to infer how much electrolysis has happened, the rate of electrolysis. After that, instead of 1 teaspoon, let's say I put 3 teaspoons, then 5, and then 8 or 10. And I can continue to do that. And the question I have from all of you is, what do you think will happen? What's your prediction? So as we continue to increase the amount of salt dissolved, the amount of rust collected in given time
will be more.
It will increase, you are saying. Okay. And basically, we are going to infer the rate of electrolysis based on the amount of rust, as I just said. So the 4 options I'm giving you are, first option is it increases and continues to increase. Till if we, let's say, I add 15 teaspoons of salt, then I get a certain rate. I add 20 teaspoons, then it will be more than the rate of electrolysis will be more than the 15 teaspoon situation. Second option is that it increases initially and after some time it stops increasing. Third prediction is it increases initially, but after some time. So if I add more salt, then it will start decreasing after that. And the fourth one is initially it will decrease and after some time it will stop decreasing. It will remain unchanged.
Sir, I think so. It should be increases initially, but decreases after some time.
Okay, so
Sir, I think it will be
I think
the
it would
second
be B.
point.
Yeah, I think it should be B part.
Second choice.
Yes, sir.
Be second choice.
Okay.
So second choice.
So let me do this. I'll launch the poll question, and what we'll do something interesting. I'm also going to give options for a hypothesis, that what's the reason you believe this. But before we come to the hypothesis slide, let's first collect our prediction. So I've launched a poll question. Select the option you think is the correct answer. So we are 27 of us, excluding me, Javeria, Ashray, and Shivani. So I'll end the poll after I get, let's say, close to 70% responses. So 18 out of the 27 of you have responded. Okay, I'll end the poll here and share the results with you. So as you can see, 11%, so 2 out of the 19 people who have voted have said it will increase and continue to increase, which means it will not stop at any point. If I add 50 teaspoons, then it will be more than the rate of electrolysis, let's say with 45 teaspoons or 40 teaspoons. 14 out of 19 have said it will increase initially and then remain unchanged after some time. So it will, if you plot the graph, then it will increase and then it will plateau after some time. It will become flat. 2 out of 19 have said it increases initially but decreases after some time. And 1 has said decreases initially but remains unchanged after some time. What we will do is we'll come back to this question after we look at the hypothesis options, as I said. So I'm giving you 4 options. Ideal would be that you come up with your own reasoning, but we'll do that with the second activity. Here, I'm giving you 4 different type of hypotheses. First one I'm saying is, as we add salt, the number of charged particles in the electrolyte that increases, and because of that, the current also increases, the amount of current which is flowing, and that's why the rate of reaction increases. Second, I'm saying is as electrolyte is added, the liquid changes its state from liquid to semi-liquid because there are more number of particles now, and hence it brings the particles closer. So for the same reason as, let's say, through solid, the connections between particles is easier, and for that reason the current will also pass through easily. So that's why the current will increase. Third, I'm saying is the positive ions from the electrolyte, they get attracted to one of the electrodes. I'm assuming you all understand what I mean by electrode. The two nails are your electrodes. So the positive ions go to one electrode and negative to other electrode. And because of that, since one side the positive ions have got collected and negative on the other, there is a potential difference, as we say, the charge potential, which is also called as the voltage. So because a potential difference is built up, so the voltage which is supplied to the electrolysis system, that voltage increases, and hence the rate of electrolysis will increase. And fourth hypothesis I'm giving is pure water conducts electricity better than impure, as impurities in the water hamper the flow of electricity. And because of that, probably one can infer that the rate of electrolysis will decrease. So let's do one thing. I'll launch the hypothesis poll question first, and we'll come back to the prediction question based on this, in case any of you want to change your opinion. First, select the hypothesis which you think is the correct one. I have 37% votes till now. We'll wait for some more time. Okay. This time we have managed to get 20 votes. Let's look at the spread in terms of the votes. So 7 people have said the number of charged particles present in the electrolyte increases, because of which the current will increase and hence the rate of reaction. So 35% have opted for hypothesis A. 10%, so 2 out of 20 have said as you add electrolyte, the particles come closer, and hence the this helps in making the current flow easier. And 9 out of 20 have said there is a potential difference getting built, so the voltage supplied to the system increases. And interestingly, 2 out of 20 have also said that pure water conducts better electricity in a better way. When you have impurities, it comes in the way, which means if you add salt, it will hamper the flow of electricity. And hence, so now let's do one thing. Let's go back to the prediction question and see if our response has changed. So just 1 minute. I'll relaunch the poll. Yeah. We already have 57% responses. We'll wait for just a little longer and can end the poll. Okay, I think we have only 17 votes, but I'll go ahead and end the poll. Okay, so out of the 18 people who have responded, this time no one has said the rate of electrolysis decreases initially as you add salt. Last time we had a couple of people who had selected this as an option. 4 have said it increases initially but decreases after some time, and majority have said increases initially and remains unchanged after some time. 1 person has said increases and continues to increase indefinitely. Okay, so what's the purpose behind doing all this discussion, right? The idea is that in any scientific inquiry, it's important that we have some kind of so once the problem statement is given, the question is given, then we have some kind of a prediction that what's my current thinking and a reasoning behind it. So the hypothesis is equally important, and they both go hand in hand. As we could see, we first made a prediction, but when we looked at the different options, different theories, the 4 hypotheses, and some of us also thought of changing our opinion. Sometimes listening to other person's hypothesis also makes us change our thinking process, and that's why what we will do next is get into small groups and hear out from other people and see if that leads to any change in our hypothesis, leads to any correction in our thinking. And tomorrow we will actually conduct the experiments, collect data and validate, and hopefully it should be clear which out of the 4 predictions are correct and which out of the 4 hypotheses is the correct one. Tanish, if you can switch on your video, we can see. Only thing I'm concerned is if you have already concluded either ways, one of the predictions, I don't want that to come in the way of the thought process of other people. So can you just hold on? Maybe one of the ways to do it, Tanish, is to show this in your smaller group. We are going to put you into breakout rooms. So there in your group, you can show this. In any kind of group discussion, it's important that we have some kind of rules set, because otherwise, when we are like 4 or 5 people thinking together and wanting to share and talk, we may end up cutting each other. Can you all very quickly share what are some of the ground rules that you would like to set for the group discussion that you'll have in the smaller groups? And you can unmute yourself and speak. Okay, Prisha is saying you wait for your turn, raise hand. Okay, Bhaskar, that's also very relevant. And these are some of the very standard ones, so you can share whatever comes to your mind, share from the top of your mind. Don't think too much about this. Equal participation from all members. So what I want to draw your attention to, Abhinav, is there's a difference between what we want to achieve, between what we desire and the method to achieve it. The rules will help us. So rules are your method to achieve that we get equal participation. So can you suggest a rule which will help us ensure that everyone is able to participate. Mohana, today's class, what we are doing, I'm clear about that, and that is to have a group discussion.
So maybe
we are, yeah, go ahead. So today's session, we are now going to put you into breakout rooms. Next session, we will actually conduct the experiments and verify our hypothesis. Okay, so we can go ahead and get into the breakout rooms, but before that, let me just state the ground rules very clearly so that we all are clear about it. So these are the 4 main points to keep in mind. One is, so what do we mean by putting down? So sometimes unknowingly, when we are confident about our opinion, about our thought process, we unknowingly disrespect others. So just be mindful that you all the teammates that you have, they all deserve as much respect as you. Second, will as one of you said, will wait till the other person finishes. But on the other hand, we also maintain that that no one speaks for more than 1 minute, so as to moderate and also capture the thoughts of all the team members. We will have one group leader who will be selected randomly. So it's not really based on any of the abilities that we have judged. We don't have enough data about you, but we'll still select one group leader for each group. So the group leader will keep track who has raised hand and keep putting in the queue and ensure that everyone gets a chance. Note that group leader is also one of the participants, and it's important for us to collect the opinions of the group leader as well. Before we put into your groups, let me show you the form that you are going to fill. The group leader is going to do that, and what I also request each group leader to do is to share the screen and fill this form so that rest of the team is also involved and they know what you are filling. So the Google form will have some basic information. So the group leader's email ID and name, and after that, all the participants in your group, you capture their names. So you'll not have less than 3 and you'll not have more than 6, and hence 3 names are mandatory, other 3 are optional depending on how many people you have in your room. Before you get into discussion, capture the predictions from each of your teammates for the 2 questions that we just asked. What's your predicted result and what is your hypothesis? So capture that for all the participants, then have the debate, try convincing each other, and post discussion, if there is any change in opinion from anyone, then you capture it here. So let's say based on the discussion, Prisha gets convinced that it's not option A, but it's option C, and hypothesis is also different, then here we write Prisha's name, and the new response would be that, oh, now I'm opting for prediction C and hypothesis B. And this is all optional, so it's likely that no one changes their opinion, and that's perfectly fine. Okay, so I will share the link to this form in the chat window now, and Javeria and Shivani can put you into the respective breakout rooms. Any questions from anyone?
So when will you make the groups?
Groups, Javeria, I think we can start making the groups.
Vishal, should I put 4 per, so like 6 rooms, 4 in each? There's around 27, including the 4 of us. So Does 6 rooms seem fine?
6 rooms, you mean 4 in one room?
Yeah.
Let's reduce that the number of rooms if for whatever reason. Yeah, let's have close to 5 in each room.
5 in each room.
So
Okay.
5 rooms are sufficient.
5 rooms or 5 in each room, Vishal?
5 rooms.
5 rooms.
I mean, aren't the two same? Because I'm assuming we are around 24. You said. Oh, I can see that we are 4 of us, so that will make it 22. Yeah. So then, yeah, we'll still need 5 rooms, I think. So 4 to 5 per room, basically.
Are we assigning the leaders or they are going to do it themselves, Vishal?
No, let us assign. It
Okay.
will just make it faster. So Ashray, you can do room 1 and 2.
Okay.
Javiria, you can handle room 3 and 4, and Shivani, you can handle room 5. And when I say
Shivani is not here, Vishal. She's got fever, so she left after her part. Yeah,
okay.
Deepa is here though.
Yeah, so Deepa, you can handle room 5. And when we say handling, it's only about getting them started. In case there are any questions or doubts, we can support.
Okay.
So
Krish,
Ashray, I'll be taking room 3 and 4.
Yes, Javeri, I'll be taking 1 and 2.
Okay.
Yeah.
Krish Kumar, can you join your room? You have been assigned to room 2. Can you please go to your respective room? Krish Kumar? Krish, are you able to hear me? Sujan, any reason you came back? You were assigned to a specific room, right?
Yes, sir.
You were assigned to
Sir,
room 2.
unknowingly I came out, sir.
Yeah, can you join back? You are in room
Yes,
2.
sir.
Yeah.
Yes, sir.
So, Krish, since I'm not hearing from you, I'm removing you from the meeting. If you're interested, please join back and unmute and let us know. Okay?
Sir,
Yes, go ahead, Sujan.
sir, in that group, what I should discuss, sir?
You should discuss about the question that we just I said enough about it, right?
Yes, sir.
So does the concentration of salt have an effect on the rate of electrolysis? That is the question. So there, what do you think? Here, that's so your opinion you should share with your teammates and hear them.
Okay, sir.
Okay.
Thank you, sir.
Okay. Karur and Gauri, any reason you came back to the main room? Can you join your respective room, please? Gauri, you are part of room 4. Karur, can you join your room, please? Yeah, I'm just asking you to join your room, Karur. Please join room 4.
Excuse me, sir.
So one group has come back, is it? Or is it two groups? Who was the group leader here? Bhaskar, were you part of that group? Dan Paul?
Yes, sir. Group 1.
Yes, even I'm part of group 1.
Yes, sir, group 1.
Okay, so group 1 has returned. So Bhaskar, I can see you have submitted. Aditya has also submitted. Aditya's group hasn't come back. How was anything specific, Bhaskar and team, which came out in your discussion, where, let's say, any of you managed to convince the other person to change the opinion?
No, sir.
No. So the discussion didn't happen, or
yes,
you?
So
Okay.
it was a very smooth discussion, according to me.
And when you say smooth discussion, can you elaborate? Is it that everyone was aligned?
Yes, sir.
Everyone
No
voted for
problem.
the same. Everyone voted for the same hypothesis and prediction.
So no, sir, for the last one, how much I remember, Dane and Ehan changed his view, and Dane or one more Gopika did the same third option.
So in your group, I can see that all the four voted for increases initially and remains unchanged after some time. But hypothesis, I see that different people had different thoughts. So two of them said that as electrolyte is added, the liquid changes its state to semi-liquid. And two people felt that the positive ions get attracted to one electrode and negative to other. So the voltage increases. And you are saying Ehan changed the opinion. So new response is option C. And option C is what? The change in voltage. Okay. Okay, we'll come back. Let me see the status with other rooms. I see that people have started returning to the room. 1 is done, room 2 is done, room 4, 5, and 3 are still happening. Three is also done. Okay. Okay, those of you who have come back to the main room, I've put the message on the rooms which are still open where the discussion is happening. So they will wind up in 60 seconds and we can resume after that.
Okay, sir.
Sir, sir, are we going to do any activity tomorrow?
Yes, we will conduct the electrolysis activity multiple times, collect data, and then discuss.
Okay, sir.
So till other groups come back, or no, wait, I see that all rooms are closed now. Good. I'll quickly share the spreadsheet where the responses have been collected. I wanted to highlight a few things. So this is the first group. So this group, the prediction, almost everyone, no, actually all four have said the rate of electrolysis will increase initially and then remain unchanged after some time. And the reason was divided. Two people thought it's because the voltage supplied to the system will increase, and two people thought as you add electrolyte, it becomes semi-liquid and hence the particles come closer, so the current flow is easier. But after the discussion, Ehan decided to change and also go with some of the other people in the team and opted for option C, which is that the voltage supplied to the system increases. This group also, the popular one was increases initially and remains unchanged after some time. One person has opted for decreases after some time. And the hypothesis, interestingly, the voltage supply changing, that seems to be a popular hypothesis. And many people have also opted for this theory that pure water conducts electricity better than impure, as the impurities in the water hamper the flow of electricity. It would be good to check on some of these basic concepts, and that's the idea behind going through this process of making prediction and forming hypothesis. So if you pay attention, it's one specific type of competencies, specific type of ability which gets exercised when you make predictions and make your own hypothesis. That is the ability to apply your past knowledge, and if the past knowledge, the concepts are not clear, then the application, it will also show up in the application, that there you'll get confused and the prediction hypothesis will be incorrect. There are other two types of abilities when it comes to scientific literacy. There's another ability which is that of drawing inferences from data. So collecting data and drawing inferences. And there is a third ability which is to design and evaluate any scientific investigation. Hopefully we will get an opportunity to experience all of them. Okay, so now that we have a mixed opinion from different people, if you had to conduct the electrolysis experiment again, and if required multiple times, what exactly will you do? What will be the experiment that you would like to conduct to conclude it for sure which prediction is correct and which hypothesis is correct?
So instead of putting salt into the water, I'll just check putting the tap water without mixing the salt, so that the nail get bubbles and brown deposition on that.
But let's say you do get bubbles and you also get brown deposits. What will you conclude from that?
Like if the salt is there in the water, if I take the tap water and if I even see the bubbles and the rust on the iron, then I'll conclude that if there is a presence of salt and not salt, if there is if the salt is in water and not in water, but the electrolysis and the brown deposition on the iron takes place.
But what's the question that we are trying to find an answer to?
Like what will the dissolve the salt? Like,
will the rate at which electrolysis happens, will that change as you change the salt concentration, right? And in a way, what you are suggesting, Vinyashri, is that you'll reduce the salt concentration to 0. You'll not add any salt and test that extreme condition as well. So what you should observe is not just whether bubbles are appearing and brown deposits are happening or not. You should also observe the time for the brown deposit to happen. Other ways that you keep that setup for 10 minutes, the way you'll keep the setup with salt for 10 minutes, and observe the amount of rust getting collected in both cases. Because inferring whether salt is required or not is a different question. Here, the question we are trying to find an answer to is, does salt change the rate at which electrolysis happens? So the speed of reaction is our real question. So you must observe the amount of rust collected as well.
Sir, I think that we can keep on increasing the amount of salt gradually and then measure the amount of time taken, and based on that we can create a hypothesis also.
So you'll observe the amount of time taken for what? What will be the event that you'll wait for?
Sir, that suppose we have taken first 1 teaspoon of salt, and then we will wait for 10 minutes and then measure the amount of rust that is produced. Then same way we'll keep on increasing the amount of salt gradually and measure the amount of rust. That is
so what you are saying, Prisha, is the time you'll keep fixed.
Yes, sir.
So you'll always wait for 10 minutes. You'll keep changing only the salt concentration and collect the rust and see how much rust gets collected in 10 minutes. And how exactly will you collect the rust?
Sir, we will do that filtration process.
Okay. So only problem with the filtration process is the rust. If it gets stuck on the filter paper, you'll not be able to measure the mass of the rust. And anyways, I don't know if you all have weighing scale at your home. So one of the options we were thinking is, on the nail itself, some rust will get collected. So once the nail dries, using a sandpaper or any other rough surface, if you rub and remove the rust and measure the volume of the powder. But the filtration that you are suggesting, Prisha, that would be the ideal way. Only thing is, by visually inspecting the amount of rust collected on the filter paper, you cannot conclude.
Sorry, Vishal, just want to let you know it's 4:35.
Yeah. I just want to see if there are any other ideas on how to conduct the experiment. Someone who thinks differently compared to what Prisha proposed. Bhavini, Bhaskar, Tanish, Dan Paul. Just one second.
Instead of giving
Yeah, go ahead. Go ahead. Sorry, who was speaking? Please go ahead. Okay, maybe there are no other specific thoughts. Let's conclude the session.
Yeah,
Let me go ahead.
Yeah, I'm Bhavi. Instead of giving it a particular point of time, we can just leave it like for until the resting is fully done, and then measure the rate of.
And how will you know? What exactly will you observe to find if the resting is fully done?
Yeah, the particles will be like coming down, and then the bubbles will also be getting stopped at a particular time, right?
Yeah, so when do you think will the bubbles stop appearing? See, as long as current is able to flow and your cell has any electric power, the bubbles will continue to appear. So bubbles will stop, the reaction will stop when your cell is fully drained, the battery is fully drained. So in that sense, do we have an end to the experiment? Probably it's there, but it would be a very long process. So you can either infer the rate of electrolysis from the amount of rust collected, or based on the time taken for the first rusting process to appear on the nail. So let's say if you observe after some time, it starts dropping from one of the nails, the brown particles. So the first event when that occurs, if you observe the time taken for that event to occur, that would also be an indicator of the rate of electrolysis. So what you need
okay,
to,
so
yeah. And if you think about it, this process, as we are thinking of designing the experiment, that is the third competency, and we need to be mindful of what are the variables you will control, what are the variables you are going to observe. So you can either observe the amount of rust collected, which can again be done in two ways. As Prisha was saying, you filter and measure, but then you need to see which one is more accurate. Other ways that you sandpaper from the nail and then collect the amount of powder. Other variable you can observe is, as Bhavini was trying to suggest, that you wait till the end, and then at the end you collect the amount of rust. Fourth possibility is to measure the time. So the dependent variable is being changed. The independent is constant. It's always the amount of salt that you add. But the dependent variable we are observing, that is different. So the fourth possibility is to measure the time taken for the first event of rust to occur. The important thing is I want you all to come prepared with this material tomorrow. It's a little investment of money in terms of getting multiple AA cells. You'll probably need 4 or 5 of them, because you want to control the voltage and current that you supply to the system, and hence a fresh cell used each time will give you the correct data. Also, you can't mix, let's say once you try the 9-volt battery and next time you try the 1.5 volt, that is AA cell. Please don't do that. Ideal would be to have 4 or 5 of these AA cells so that you can conduct electrolysis multiple times. The reason you require 25 teaspoons of common salt is that way you get data which is well spaced. Let's say once you add 1 teaspoon, next time you add 4, and then 8, and next time say 12 or 15. Volume has to be fixed to 100 ml. Sandpaper, if you want to use that method to find the amount of rust. And plastic straw is, we were thinking a small plastic straw which is 1 centimeter long, you can make a cup out of that and measure the volume of rust collected and infer the mass of rust based on that. And graph paper, to plot the graph, you'll require more wire, because in case you want to have parallel setups ready, because if you want to leave it for 10 minutes long, and iron nails, you'd need multiple iron nails, preferably long enough so that they are nicely dipped. There's sufficient surface area of the nail getting exposed to water. Okay, I think we can take a pause here unless there are questions. Okay, then we will meet tomorrow, same time.